Good evening. We are in section 1.4, the last section in chapter 1, which is over solving equations. Tonight we're going to start solving literal equations. Now, literal equation, what is that? It sounds fancy, but it's not. A literal equation, all it is an equation that has two or more variables. So basically, it's an equation with more than one letter. So if you had 5x plus 2 equals 10, that's an equation because there's only one letter. If you had 5x plus 2y equals 10, there are two letters, therefore it's a literal equation. Now, a literal equation is when you're going to solve for one variable in terms of the other. So this is where it gets confusing. You're going to have one variable that you need to solve for and get by itself. All the other letters go to the other side. This can be one of the most confusing things that students solve for. But once you get it, it is so easy. But just pay attention, go through these examples, and take your time. Rewind the video if you need to. We are going to start with a very straightforward formula. A equals length times width, the formula for area of a parallelogram. Now in this problem, this is a literal equation. Why? Because you have three letters. Now, let's go over what it's solved for. A equals L times W. What letter's by itself? A. So right now, we have the letter by itself, A. So this equation is solved for A. I want to solve this equation, let's say for W. That means I want to get the W by itself. So all you have to do is look at inverse operations. So I want you to think when you have a problem like this. If you want to get the W by itself, here's how I learned it when I was in high school. I pretended the A and the L were just numbers. So I just made something up like this. How would you get the W by itself in this problem? You'd divide by 5. It's the same thing. Let's say I want to get the W by itself. How do I get the W by itself? I have to get rid of a times L. How do I get rid of a times L? I divide by L. And these L's cancel, so I'm left with W equals A divided by L. The W's by itself, and that's your answer. That's it. Let's do another example. Let's do A equals LW again, but now I want to solve for L. I want to get the L by itself. It's the exact same thing. How do you get rid of a times W? You divide by W. So in this problem, the length would equal A divided by W. And that's your answer. Let's go over another kind of example. I'm just going to make a random equation. 3x plus 5 equals 15. Let's solve it. How would you solve this? You would first subtract 5, get 3x equals 10, and then you divide by 3, and your x would be 10/3. Review, easy review. But now I'm going to take all of the numbers and make them letters. So I'm going to do this. AX plus, let's do B equals C. You are going to solve it the exact same way. I want to get the X by itself. So the first thing, pretend they're numbers. I have a times A and a plus B to get rid of. So the first thing I have to do, over here, I had to add 5, so I subtracted 5 on both sides. So how do I get rid of a plus B? I have to subtract B on both sides. So then you're going to get AX equals C minus B. You cannot combine those. They're not like terms. How do I now get rid of a times A? You divide everything by A. So my answer would be X equals C minus B divided by A. C minus B divided by a. All right, example number 1. We are going to do the exact same equation. But I want to solve for b. What does that mean? I want to get the b by itself. So let's pretend I want to get the b by itself. So I want this b by itself. If you don't know what to do, pretend this is a number and this is a number. So pretend you have something like this. 5 plus b equals 7. What would you do first over here? Well, you'd subtract 5. So what you want to do is you want to move this whole ax to the other side. So how do you move a plus ax? You just take the entire clump of letters and move it over by doing the opposite. The opposite of plus ax is subtract ax. Subtract ax. That would give me b equals c minus ax. Is the b by itself? Yes. There's your answer. Example number 2. 2y plus 5x equals 6. I want to solve for y. That means I have to get the y by itself. So 2y plus 5x. Pretend the other letter is just a number again. Pretend this is just 2y plus 5. Pretend the x is not even there. Or pretend it's like 55. How do I move a plus 5x? I want to move this entire thing to the other side. I want to get rid of a plus 5x. So I'm going to subtract 5x on both sides. Once again, you cannot combine unlike terms. So 6 minus 5x. Some of you might want to say, oh, that's just 1 or 1x. No, you can't do that. They're not like terms. So then you get 2y equals 6 minus 5x. I have to undo multiplication times 2. I have to undo multiplication. Well, to get rid of multiplication, I divide. So I divide everything by 2. Your answer would be y equals 6 minus 5x divided by 2. And that is your answer. Example number 3. 4x minus 4y equals 1. I want to get this y right here by itself. So the first thing I have to do is undo an addition of 4x. So I have to subtract the entire 4x term to the other side. That gives me negative 4y equals 1 minus 4x. I now have to get rid of a times negative 4, so I divide everything by negative 4. My equation is y equals 1 minus 4x divided by negative 4. And that's my answer. Let's do one more. Number 4. 12 equals 6x plus 3y. I want to get the y by itself. So I want to get this term by itself, so that means I have to move the 6x. So the opposite of 6x is minus 6x. That gives me 12 minus 6x, which you cannot combine. They are not like terms. I now have to get rid of a times 3, so I divide everything by 3. So I get y equals 12 minus 6x divided by 3. Now, you can leave that as your answer, but I'm going to show you one way to simplify this. You can take 12 and 6 and divide it by 3. 12 divided by 3 gives you 4. Negative 6 divided by 3 gives you negative 2x. So if you wanted to write it like that as well, you could. Example number 4. It says, now we're not writing the entire thing down, but it says the formula for the surface area S of a cone is S equals pi r squared plus pi r L. Solve the formula for the slant height L. Now you're going to look at this and go, Mr. Humphreys, I can't do this. Absolutely you can. I promise you, it's incredibly easy. It looks difficult. All you have to pretend is that the S is a number. Pretend that this entire chunk of letters and pi is a number. Pretend that the pi r is a number. and the L stays the same because that's the letter I want to solve for. What would you do first in this problem? Well, you'd subtract 7. Subtract 7, you get 5 minus 7 equals 2L. Last step is divide by 2. You're going to follow the exact same steps. Now you're going to be like, Mr. Humphreys, this is way different. I promise you it's not. The first thing, here's what you need to get rid of. This entire chunk, pi r squared, needs to move to the other side. So what's the opposite of plus pi r squared? Minus pi r squared. So you're going to get s minus pi r squared equals pi rl, because that canceled. Now I have to undo multiplication. How do you get rid of times pi r? How do you get rid of times pi r? You divide by pi r. And that's your answer. The pi r cancels. You're left with L equals s minus pi r squared divided by pi r. That's your answer. You're done. Another 2 examples. Now in this problem, I want you to solve the formula for the purple variable. So I want you to get the purple variable by itself. I promise you, this is so easy. Just take your time. So the first thing I need to do is get the p by itself. So all I have to do is get rid of a times rt. How do you get rid of a times rt? You divide by rt. rt divided by itself is 1. That cancels. So you're left with p equals I divided by rt. Done. Over here, I want to get this h by itself. So that means I first have to move this entire chunk over to the other side. 2 pi r squared. It'd be just like if you put plus 5. How do you get rid of plus 5? You subtract 5. How do I get rid of plus 2 pi r squared? You subtract 2 pi r squared on both sides. That gives you s minus 2 pi r squared equals 2 pi r times h. Now, all I want is to get this h by itself. So I have to get rid of all of this. So if that was 2h, how would you get rid of 2h? You divide by 2. Well, how do you get rid of 2 pi r? What's the opposite of times 2 pi r? You divide by the whole thing, 2 pi r. Divide by 2 pi r. Your equation, that all cancels, is h equals s minus 2 pi r squared, all divided by 2 pi r. There's your answer. Example number 7. We're going to write down the formula for area of a triangle. And I want you to get the h by itself. Now, the only extra thing here is a half. You have to get rid of a half. Please, please, remember, the only way to get rid of, well, not the only way, but the easiest way to get rid of a fraction is by multiplying by the reciprocal. So the very first thing, if you see a fraction, get rid of it. So how do you get rid of a times a half? You times by the reciprocal, which is 2 over 1, which is just 2. That's all it is. So 2 times a gives you 2a. 2 times a half, that cancels. 2 times a half is just 1. So you're left with b times h. Once again, this equation right here is as easy as 2 equals 2h. That's it. How would you get rid of a times 2? You would divide by 2. How do you get rid of a times b? You divide by b. So h equals 2a divided by b. Example number 8. I want you to solve for the f. Get the f by itself. Step 1. Get rid of your fraction. You multiply by the reciprocal. So what's the opposite of timesing by 5/9? You would times both sides, or you can use parentheses, by 9/5. This is incredibly easy. 9/5 times c is 9/5 c. That's it. Equals the 5 divided by 5 and 9 divided by 9, they're gone. you're left with F minus 32. The last step, how do you move a minus 32? You add 32. So you're going to get F equals 9/5 C plus 32. And that's your answer. They're not like terms. You cannot combine them together. Now, we are going to go one step further. It says, oh, I'm going to add this. Lightning, the temperature for lightning is 30,000 degrees Celsius. Determine what that is in Fahrenheit. Well, F stands for Fahrenheit. C stands for Celsius. This is Celsius. This is going to get plugged in for C. So all I do is plug this in. Let's go back to about 6th or 7th grade and plug it in. All I do is take the 30,000 and plug it in for C. So now you multiply. 9 times 30,000. That's it. 9 times 30,000 divided by 5. 9 times 30,000 divided by 5. So what is that? 9 times 30,000 divided by 5. It's 54,000 plus 32. So the degrees Fahrenheit is going to be 54,000, 32 degrees Fahrenheit. And that's your answer. Very simple calculations. It looks a lot harder than it actually is.